Hi, everybody. Jeff Berryman here. I'm sorry I can't be with you in person today, but we thought we'd try out this little video presentation format and see how well it works. Today, I'm going to be talking about connection management for AES67 and SMPTE 2110-30 using AES70. As many of you will know, AES70 is an architecture for control and monitoring of media devices over networks. Generalized streaming connection management is a key feature set of AES70. It's called CM4 for Connection Management 4. It's the fourth version. We think we got it right this time. A specialization of AES70 for a particular purpose is called an adaptation. So AES7021, the new AES67 SMPTE 2110-30 connection management standard, specifies a CM4 adaptation. Here's the AES70 standards family. On the left, you've got the core standards, AES70-1, 2, and 3, specifying the framework and the control model details and the binary protocol for all AES70 applications. And then on the right, you've got adaptations. There's AES70 21, 22, and 23. 21 and 22 are out for public comment. 23 still under development. And so 21 is our topic today. That's using AES70 to manage AES67 and SMPTE 2110-30 media transport connections. 22 is for AES70 management of Milan media transport connections, and 23 is using AES70 for Dante media transport connections. Let's talk about some use cases. Here are the two main scenarios that this presentation is concerned with. They're very similar. The one on the left is for AES67, the one on the right is for 2110-30. In both cases, we've got some AES70 controllers talking to some AES70 devices that are exchanging media under the control of AES70. There's a PTP clock in there. Didn't want you to think we'd forgotten about that. But basically, both of these scenarios are very, very similar. A couple other scenarios. The one on the left is the case in which AES60, AES67 devices are using SIP, Session Initiation Protocol services, to create connections. That's only defined for the AES67 standard. 2110-30 doesn't do that, but in this case, because the two devices are talking to each other, the AES70 controllers only have to talk to one of them. So you see there is a dotted line on the right indicating that it really isn't necessary for the AES70 controller to talk to both sides of the connection, unlike the other cases. And then this case over on the right is just sort of a generalized case to suggest that there will be many circumstances where AES70 controlled devices will be mixed in the same network with non-AES70 controlled devices. And, we want to show that that's a possibility, that there can be non-AES70 control and connection management over here, maybe web-based SDP or something like that for connection management. And that the devices that are controlled that way can interoperate seamlessly with devices that are controlled by AES70. Here are some more use cases. I've left out the controllers because they're always all the same. On the left, we have redundant networking, and we show double network connections. In the case of 2110-30, there'll be ST22027 conformant connections. The AES70 control design supports those. It actually supports redundancy, not just double redundancy, but any number of redundant connections for both AES67 and 2110-30. On the right, there are just some pictures designed to kind of suggest that it's possible to have any kind of mixture of network types in a device. You can have multiple AES67 networks, for example, or multiple 2110 networks, or various kinds of mixtures. And the AES70 control architecture allows controllers to treat all those independently. They don't trip over each other, so there's really total flexibility with regard to device and network configuration. In general, AES70 connection management has a lot of capabilities. I just kind of listed them here. We can sort of run through them without getting into too much detail on each one. Physical or virtual devices, AES70 can control real devices, hardware devices, or cloud-based devices or server-based devices with equal facility. Any number of media transport networks and media transport network types per device. Unicast or multicast. No constraints on stream formats, channel counts, and so on. The standard does define support for all existing AES67 formats and 211030 profiles, but other formats are completely possible. No constraints on clock rates or number of clocks. No constraints on number or type of time references. Straightforward extension to other media formats, including encrypted ones. Flexible built-in features for connection negotiation support. There's a nice table structure in there that allows devices to know and find out what kind of formats each other can handle. And of course, the whole thing is customizable, as are all AES70 applications, due to AES70's object-oriented design. Network options for AES70 protocol transport. You can pretty well send AES70 over any kind of normal IP network, TCP, secure TCP with SSL, UDP, or WebSocket. There's also an option to send a defined specification for sending AES70 protocols over simple point-to-point links like serial links and so on. Those aren't IP. They're just what you find in USB and Bluetooth and inside devices, for example, and so on. AES70 traffic is normal IP traffic. Doesn't use a lot of bandwidth. Doesn't need tricky latency requirements. It's an efficient, lightweight protocol. Here's a brief overview of how AES70 works. The intention is really just to create a conceptual framework that'll make it easier to understand some of the concepts in the rest of this presentation. An AES70 controller, a device, is just a box of objects. If you look at this picture over here on the right, it's a little small to see maybe, but all these little symbols in here are all different processing objects like gain controls and amplifiers and switches and stuff that handle the audio stream and ancillary functions. So each one of these represented by an object. We'll see more about that in a couple of minutes, but basically each object is a control API for an internal device function. There is AES70 in action. AES70 commands talk to AES70 objects. So here's an AES70 controller. It's issuing commands. These commands go over here to these control objects, and the control objects ultimately talk to internal device functions. The internal device functions are not defined by AES70 at all. Only these control objects are, and these control objects surface these little wavy green interfaces that represent API fragments for the device. So you've got this isolation. So just to reassure developers that AES70 does not dictate how you're supposed to implement your device inside. Monitoring, important topic. AES70 devices can automatically notify controllers of status and parameter changes of any parameter, any status in the device. The way it works is the controller subscribes to the parameter to a parameter it wants to watch. When a change occurs, and what's called an event occurs, here we go, an event, and then when a controller is subscribed to if a controller is subscribed to that event, the device sends it a notification. So in this picture over here, here goes an event. Something happens in this internal logic element that results in a signal coming out through the control interface, and notifications are emitted to the controllers that have subscribed to this particular event. In this example, only 2 of these 3 controllers have subscribed to the event, so there are only 2 notifications emitted. The importance of this for AES7021 is that this feature is what's used for connection status monitoring. So with the appropriate subscriptions in place, a controller can discover changes in connection status immediately for whatever kind of change happens. Now we're going to talk about the connection control model. The connection control model is defined on the next slide. A connection control model is the device's media stream connection mechanism as seen by the controller. So the connection control model defines the control interface that AES70 publishes on the network. And you see here that in fact what it is it's a sum total of all these little wavy green lines that we saw in previous pictures. You take all the little APIs for all the little objects that you've got to manage your connections, put them all together, and that is your connection control model, and that's what controllers have to deal with. Inside the device, of course, things could look very different, but the important thing is that if the device just publishes the correct interfaces here, everything will work. The CM4 connection control model's got a lot of bells and whistles, so to avoid a confusing slide, we'll just build one step by step. We'll start with a couple of devices. Let's say one device wants to send a media stream to the other device. And the other device wants to send a media stream back. Now, these media streams need some kind of abstraction, software abstractions at either end. So we'll create these things called media stream endpoints that are either emitters or receivers of media streams, beginning points or ending points. And these media stream endpoints have to belong to something, so we're going to create a couple of transport application objects, we call them. These are AES70 control objects, and these objects will own the media stream endpoints on the two sides of the connection. So we have one in this device, one in that device, and the media stream endpoints inside. Now, we have to have some way of holding network parameters, so let's define a couple other objects called network objects that have little data structures inside to hold the IP parameters for the two respective devices. In this case, there's only one network object because the device only belongs to one network. In this example, that can vary, but for now, we'll have one each. And then we want to figure out what's going to happen to the audio if these are multi-channel media streams and so forth. So all these green lines are audio coming and going in and out of the media stream endpoints to and from internal processing, signal processing functions inside the device. There's a flexible scheme. CM4 is very flexible as to how these stream channels can be mapped to the processing channels. There's sort of a full matrixing function in here in these endpoints to do that. Now we have a couple of controllers here, and you can see how these controllers are talking to all these objects we've populated the devices with. There's a couple of dotted lines over here because in devices that have internal processing functions which are AES70 controlled, there will be a protocol relationship here. But if the device's internal processing is not controlled by AES70, maybe it's just controlled by knobs on the front panel or something like that, then there will be no AES70 relationship between the controllers and the processing, so these dotted lines won't exist. It just depends on how things are built. So there's a lot of flexibility. There are a lot of features in the CM4 connection control model. We have a little list of them here. And we'll have some detailed drawings following this slide. But the main features I want to point out today, highlight today, are flexible media clocking control with multiple clocks or single clocks for everything. Flexible time reference management, so you can have multiple PTP domains if you want, or even other kinds of time references that aren't even PTP. Control of redundant networking, including ST22.7, control of SIP managed sessions, as we saw in the use cases. Cooperation with SDP control implementations is an interesting discussion topic there, and lots of good stream format description capabilities for effective connection negotiation. Here's a simple case of clocking control. We've got one of these devices that we've been looking at, and inside the device we have a media clock object that contains information such as sample rate, and that's used by both these endpoints in this example. Media clock object is synchronized to the rest of the world by a time source object, which will normally, of course, represent a PTP stream. And the controller can talk to both of those objects to manage the clocking, and so it'll change sample rates and change PTP sources and stuff like that. So this is the case of just a simple clock. Here's a slightly more elaborate clocking case to give you an idea how this stuff can work. In this case, to separate it, each endpoint has a different clock, and here they are. But those two clocks are synchronized to the same time source, so they share a time source. Pardon me. The controller can talk to all three of these objects, and of course, lots of other configurations like this are possible. I'm just showing two, or just showing this one and the previous one. Redundant networking. This is interesting. Here we have a redundant networking configuration of the connection model. There are two networks in this case, and there's just one media stream endpoint in this case. It belongs to a media transport application object, but in this case, the application object is associated with two different network objects, each one containing IP parameters and so forth for its respective physical network. And then there are links from these network objects to the media stream endpoints, so that the system knows that this particular media stream endpoint is in fact fed by a redundant pair of networks. Hiding behind this in the device implementation, of course, there will be a packet combining algorithm to do the seamless reconstruction that is done by 2022-7, for example, in order to provide a flawless set of signals from this media stream into the rest of the device. Here's how session initiation protocol control, SIP control, looks for AES67 devices. We introduced this new kind of object called a session agent. The CM4 session agent concept is kind of generalized, and it's used for a variety of things. This example used it for SIP control. The Milan adaptation AES70-22 uses it in quite a different way. But in general, a session is a software abstraction that's aware of both ends of a connection. And so in this case, the session agent holds session data for these two media stream endpoints that will have information about the far ends of the connections and so forth, and the SIP servers that are involved. And the AES70 controller, of course, can talk to the agent and observe and modify all these parameters. SDP. AES70 doesn't directly use SDP. You can't just give CM4 an SDP string and have it create a connection. CM4 works by commands and responses, as we've seen before. However, it's recognized that AES70 needs to cooperate with device functions that do work on SDP, and so there's this kind of shared logic architecture. You know, what you see over here on the right is you see an AES70 setup with, we've seen in previous pictures, with AES70 interfaces and whatnot, and the control objects. And then here there's an SDP controller and an SDP protocol coming in to an SDP interface. Both of these setups, the blue one and the brown one, both operate ultimately on the same internal connection logic that's actually doing the media transport. So there's a shared control situation here, and primarily through the use of notifications, you know, CM4 can properly implemented will report SDP-induced changes back to AES70 controllers, and hopefully the SDP interfaces will report back to the AES70 controllers so that everything can stay in sync. Result would be that you'd have a setup in which connections could be made either through the AES70 route or through the SDP route. So we're pretty getting close to the end here. A few final comments just to sort of give a reminder of the overview. CM4 provides a fully engineered standardized management capability for AES67 and ST211030 stream connections. The fully engineered aspect is important, and this stuff has been developed through the collaboration of a lot of pretty experienced people, and so it represents a kind of a low cost and low risk opportunity for developers of new products or new product features. For existing products, CM4 can cooperate with other connection management mechanisms in the same device, gives a good on-ramp to parallel services, legacy services, and so forth. Going forward, CM4 will provide a unified connection management scheme for all kinds of media types in all kinds of platform environments, be they physical, virtual, or mixed. And of course, the final opportunity there, once you've implemented CM4, you can easily extend your scheme to provide full device control of device functions other than connection management. So you can get a really, look forward to a future of sort of intelligent collaborating devices on a number of levels. A little update on current work. AES70-21 will be published within a couple of months. The Dante adaptation, AES7023, will come later. It's going to be based, I just wanted to say that it's just going to be based on public Audinate information with no proprietary content. You will need a Dante license to implement the standard, but the standard itself will not have any licensed material in it. Also coming is a JSON version of the AES70 wire protocol. It's going to be called AES70-4, functionally equivalent to the current binary protocol, but some people would prefer JSON. There's also going to be a kind of an XML, the corresponding XSD XML specification of JSON in the same standard, if that's your cup of tea. And then lastly, in the new year, we're going to be working on application notes and other kinds of assistance for using AES70 with virtual devices. We think there's a big opportunity here. AES70 is really kind of ideally structured to work with both physical and virtual devices, and since that's a current topic, we think we should produce some helpful information about that. Here are some links. OCAalliance.com. The OCA Alliance is the trade association that develops and maintains the open control architecture, which is the technology that AES70 standardizes. The OCA Technical Committee develops standards recommendations for the AES and gives them to the AES, and they turn into AES70 standards documents. That's the way that this thing gets developed. OCAalliance.github.io is a resources for AES70 product and tool developers, downloads and stuff. AES2, this one here, AES2.org publication standards store. This is called the AES standards store. That's where you go to purchase and download AES70 standards documents. And the last one, AES.org standards comments, is where the AES publishes standards drafts for comment. That's where AES70-21 is sitting right now, is where you can go and get a copy if you want and comment on it. Thanks for listening, folks. See you next show.